Hello viewers, in this video we are going to discuss schedule concept in transaction concepts, types of schedules, serial and non-serial schedule, and the importance of executing transactions concurrently and its advantages we are going to discuss in this video. Let's now discuss what is schedule with an example. The order in which the operations of multiple transactions appear for execution is called as a schedule. Let us take one example for a schedule. Here in this schedule, two transactions T1 and T2 are there. Here, according to this schedule, three operations in T1 need to be executed first, then followed by that four operations in T2 and four operations in T1 need to be executed. After that, the remaining four operations in T2 need to be executed. This is what the order specified according to the schedule. As per this order only, operations in T1 and T2 need to be executed. Let us discuss the type of schedules. We can classify the schedules into two types, serial schedule and non-serial schedule. And this non-serial schedule again be classified into serializable and non-serializable, whereas serializable can be classified into conflict and view serializable. Then non-serializable schedule can be classified into recoverable and non-recoverable schedule. Here, usually this serial schedules are always be consistent, recoverable, cascadeless and strict. Whereas non-serial schedule may not always be consistent, recoverable, cascadeless and strict. Okay, it means that the serial schedule always maintain consistency, right? So it means that it never leave serial schedule whenever it is executed, it never leave the database in inconsistent state. That is, when serial schedule is executed, there is no chance for the occurrence of errors in the data items of the database. Okay, it always ensures the integrity of the database. And recoverable serial schedules are always recoverable. The meaning of this is that during the execution of the schedule, if any transaction failed due to hardware or software issue, it has to be rolled back to the previous consistent state. So if it can be rolled back, then this schedule is known as a recoverable schedule, and always serial schedules are recoverable. Okay, and the next property of serial schedule is cascadeless. It means that the rollback of serial schedule never cause the dependent transaction to be rolled back. Okay, if any transaction is rolled back in serial schedule, it alone rolled back. It never caused the dependent transactions also to be rolled back. Okay, then the next property of serial schedule is strict schedule. It means that the serial schedule never permit any transaction to do read or write data item that was updated by the uncommitted transaction. Okay, so this type of schedule is known as strict schedule. Always serial schedules are strict. Okay, and coming to non-serial schedule, it may be consistent and may not be consistent. Okay, if the non-serial schedule maintains the consistency property of the database, then it is known as serializable schedule. And if it does not maintain the consistency property of the database, then it is known as inconsistent non-serializable schedules. Okay, then we can classify serializable schedule, which maintains the consistency property of the database, into two types. One is conflict serializable, another one is view serializable. The meaning of this is that if the non-serial schedule is determined as serializable, That is, if the non-serial schedule is determined as consistent one with the help of conflict serializability technique, then it is known as conflict serializable. Or if the non-serial schedule is determined as serializable, that is, if the non-serializable schedule is determined as consistent with the help of view serializability, then that non-serial schedule is known as view serializable schedule. Then coming to non-serializable schedule. So we know that a non-serial schedule that does not maintain the consistency property of the database is known as non-serializable schedule. So that type of non-serializable schedule will not be executed successfully, right? So that type of schedules need to be rolled back. If it can be rolled back, then that type of schedule is known as a recoverable. And if non-serial schedule that does not maintain the consistency property uh, that could not be rolled back, then it is known as non-recoverable schedule. So here the very important point to be noted is that non-recoverable schedule, the non-serial schedule that is non-recoverable is very dangerous. Okay, this should not be permitted at all. Okay, okay. Even a serial schedule that maintains the consistency property, it's okay. A non-serial schedule that is serializable, that is okay. And if non-serial schedule um, that is not non-serializable but recoverable, that is also accepted. But non-serial schedule and non-serializable that is not recoverable, this is what very dangerous. Okay, so in this slide we have discussed about the different types of schedules. Okay, let us have a look on a serial schedule with examples. Just we discussed that serial schedule, it means that all the transactions in the serial schedule are executed serially one after the other. That is, when one transaction execute, no other transaction is allowed to execute. So just now we discussed that serial schedules are always consistent, recoverable, cascadeless, and strict, right? So the consistent schedule always ensures that there are no errors occurs in the database at any point in time, and a recoverable schedule uh, a recoverable schedule can be successfully rolled back in case of any failure. So we know that serial schedules are always recoverable. So even though any failure occurs during the execution of the schedule, it can be successfully rolled back. And next property of a serial schedule is cascadeless. A cascadeless schedule does not cause the failure of one transaction to roll back the dependent transaction to roll back or abort. The next property of serial schedule is strict schedule. Strict schedule does not permit a transaction to neither read nor write data item that was updated by an uncommitted transaction. So these are the characteristics of a serial schedule, and these characters are always maintained. Let us discuss serial schedule with an example. Here, um, in the serial schedule, two transactions are serially executed. That is, after the successful execution of T1, T2 starts its execution. Um, so we know that the important characteristics of serial schedule is it always maintain consistency property of the database, right? So with this important point, let us discuss this example. Here in this example, A and B data items are taken, right? So let us assume A and B values are 1000 and 2000. Okay, so here in T1, first operation is read of A. When read of A is executed, reads the value 1000, and when this instruction A equal to A minus 50 is executed, this 1000 minus 50 becomes a 950. So now A value equal to 950. So when write operation is executed, it writes um, a value as 950 into database. So we know very well read operation, it reads the value of data item from database to buffer, and write operation, it writes the value of a data item from buffer to database, right? So according to this read of b, so which is a read operation, it reads the value of b from database to buffer. So when it reads, the latest value of b is 2000, so it reads the value b as 2000. Okay, and when b equal to b plus 50 is executed, b value becomes 2050, and when write of b is executed, it writes the value of b as 2050 because it was the value calculated by CPU recently. So this 2050 is written to the database. Okay, so after doing this operations, it is committed successfully. So after the successful commit of T1, T2 is permitted to execute. Okay, in T2, it performs the read operation on A. So when it reads, the latest value of A is 950, so it reads the value. So when this operation is executed, temp equal to A into 0.1, so temp value is 95, and when it is executed, 950 minus 95, it becomes 855. So this 855 is written into database when this write of A is executed. So this 950 is replaced by 855. Okay, then very similarly, when these instructions are executed, it reads 2050, which is the value of b from the database. Then later on, when this instruction is executed, b value, it becomes 2145, which is the addition of 250 plus temp value 995, so it becomes 2145. So when this write operation on b is executed, it writes this 2145 into the 2145 into the database. um, um, Students, we all know that serial schedules are always consistent. It maintains the consistency property of the database. Yeah. Um, so, so in this example, the consistency requirement here is that the sum of A and B be unchanged by the execution of the transaction. Here you can notice at the beginning of this schedule, the sum of A and B are 3000. So so at the end also you can notice that sum of A and B are 3000. Okay, so what are the latest values of A and B? 855 and 2145, right? When these two values are added, A and B values become the sum of A and B value becomes 3000. So there is no change in the sum of A and B. um, it remains same even after the execution of the schedule also. So this serial schedule maintains the consistency property. And let us take one more example where T2 is executed, and after the execution of T2, T1 starts its execution. Okay, so even very similar to the previous example, A and B values at the beginning of the schedule is 1000 and 2000. So its corresponding values are mentioned here for each and every operation in T1 and T2. Here let us focus mainly on IO activities, like IO operations. Read operation, when it reads, its values of A is 1000, and when it writes, it writes the value of A as 900 because of the some updates it performs on A. Here temporary value it calculates, it takes temp value takes 100, and this temp value is subtracted um, from A value. So now A becomes 900. That is what written into this, right? Okay. So when this write operation is performed, it becomes 900. Very similarly, when it reads B value, it reads 2000. And after this operation, when it writes B value, it writes 2100, then it's fine. Now after the commit of T2, when T1 starts its execution, um, it reads the value of A as 900. That is the latest value of A, right? So then after this operation, A value becomes 850. Then write operation on A, it writes 850 into the database. Then when this read operation executed, reads the latest value of B, that is 2100. Then after this operation, it writes the value of B. What is the latest value of B after this operation? 2150. So this is what the value written into the database. So at last, A and B values are 850 and 2150. Okay. So it is the duty of DBMS. It has to ensure that schedules maintain a consistency property, right? So according to this schedule, the consistency requirement here is that sum of A and B, remains same after the execution of the transaction. Right here, at the beginning, A and B values are 1000 and 2000. Its sum value is 3000, and at the end, what are the latest value of A and B? 850 and 2150. Its sum value is 3000. So you can notice some value of A and B before the starting of the schedule, and at the end of the schedule also remains same. So from this we can understand all serial schedules are always consistent. Okay, it never leaves the database in inconsistent state. Okay, let us discuss now non-serial schedule, which is also known as concurrent schedule, um, in which multiple transactions execute concurrently and operations of all the transactions are interleaved or mixed with each other. As we already discussed, these non-serial schedules are always not consistent, recoverable, cascadeless, and strict. Sometimes it may be inconsistent also, right? So it needs to be detected. Let us discuss non-serial schedules with an example. Here you can notice before the completion of T1, T2 permitted to execute, right? So very similar to the previous example, A and B values are considered as 1000 and 2000. Okay. Here, as we discuss now, here the final values of A and B that was updated by this schedule are, what is the final write operation on A? Final write operation on A is this. So accordingly, 855 is the final value on A, and accordingly, final value of B that was reflected by the last write operation on B is 2145, right? So when this A and B are updated, I mean added, we will get the value 3000. So there is no change in the sum of A and B. Uh, it remains same even after the execution of the transaction in the schedule. So this non-serial schedule maintains the consistency property. Let us take one more example. So in this example, um, initially A value and B value are 1000 and 2000, but according to the last update on A and B are your last update on A is write operation on A is 950, right? So 950. Last write operation on B is this one, right? 2100, right? So when these two values are added, we will get 3050, which is not same as the sum before the um, starting of this non-serial schedule. So since there is a variation in the sum of A and B, it does not maintain the consistency property. So from this we can understand that all non-serial schedules are always not maintain does not maintain the consistency property. Sometimes some non-serial schedule may maintain the consistency property, and some other non-serial schedules may not maintain consistency property. So it is the duty of the database management system to ensure that the given non-serial schedules are always consistent using concurrency control schemes. Let us now discuss concurrent execution of transactions. Transaction processing systems usually allow multiple transactions to run concurrently. So this non-concurrent execution of multiple transactions causes several complications with consistency of data. Students, just now we discussed that non-serial schedules may not be always consistent. Sometimes it violates the consistency property, right? We discussed that concept with examples, right? So, however, irrespective of the problems caused by concurrent execution of transactions, there are two good reasons for allowing concurrency. That is, concurrent execution of transactions helps to achieve improved throughput and resource utilization and reduced waiting time, right? Here, how do we achieve improved throughput and resource utilization? So we all know that a transaction, if we take this transaction T1, it involves multiple type of activities. That is, it involves IO activities as well as it performs CPU activity also. Okay, when this transaction performs IO activity, CPU will be free, right? At the time, T2 may be permitted to use a processor. So at the same time, different resources may be utilized concurrently. So resource utilization is improved, as well as when multiple transactions are permitted to execute, more number of operations can be executed. That is, we can achieve high throughput. That is, number of operations that is executed in a given amount of time is more. Okay, so when uh, when transactions are executed concurrently, it helps to achieve improved throughput and resource utilization. The next advantage is reduced waiting time. Since number of resources are used concurrently and which executes number of operations in different transactions are executed concurrently, obviously more number of transaction can be executed in a short span of time, uh, especially when a short a small transaction a smaller transaction is waiting for the uh, a longer transaction. If the schedule is the serial schedule, a small transaction, it has to wait for a long time for the completion of the longer transaction. Okay, but in case of non-serial schedule, this small transaction no need to wait because multiple transactions are permitted to execute concurrently, right? So it obviously reduces the waiting time of the transactions. So these two are the important advantages of permitting multiple transactions to run concurrently. So as we already discussed, concurrent execution of transaction may leave the database in inconsistent state, right? So um, the concurrency control component of the database system, it has to ensure that any schedule that is executed will leave the database in a consistent state. However, we can also ensure consistency of the database under concurrent execution by making sure that any schedule that is executed has the same effect as a serial schedule. That is, the schedule should, in some sense, be equivalent to a serial schedule. Such schedules are called non. Such schedules are called serializable schedule. That is, if the given non-serial schedule, in some sense is equivalent to a serial schedule, is non-serial schedule. In such case, it is known as serializable schedule. It means that always serial schedule, it maintains the consistency property. It is always consistent. So this non-serial schedule also, in some sense, it is equivalent to serial schedule, right? It is also be consistent. In such case, this non-serial schedule is serializable. This non-serial schedule is known as serializable schedule. And this one, either the given non-serial schedule is serializable or not, we can come to know using number of techniques such as conflict serializability, view serializability, and serialization graph. Students, we have discussed about schedule and different types of schedule, the advantages of concurrent execution of transactions in this video. Thanks for watching.